In this video, I'm going to talk about the homework assignments theorems 1.24 through 1.27. For each problem, I'll give you an idea how to prove the statement. Before we talk about the theorems, we look at the definitions. So whenever we want to prove a quadrilateral is one of them, for example, a trapezoid, and we need to show at least one pair of the parallel sides. So if we have quadrilateral like ABCD, then we need to show pick one pair of sides. We prove them that they are parallel. So these are definitions: trapezoid, a quadrilateral with at least one pair of parallel sides; parallelogram, in which each pair of opposite sides is parallel. So we have to prove two pairs of opposite sides are parallel. And a rhombus, we need to prove two adjacent sides are congruent. Well, there's another definition. We can also prove four sides are congruent. Either way is fine. Actually, we can prove these two definitions are congruent, equivalent to each other. And the rectangle is a quadrilateral with four right angles, or it is a parallelogram, which means two opposite sides are parallel, and there is one right angle. So, and we can also prove these two are congruent. Probably we can take these as the review exercises later. So the square is a rhombus with a right angle. So we need to prove, first of all, it's a rhombus, which means two adjacent sides are congruent, and also we need to show there is a one right angle. So two things. And now let's look at 1.24. The measure of an exterior angle in a triangle is equal to the sum of the measures of its two remote angles. So if we recall the definition of exterior angle, so if we extend one side of the triangle to some point, and then the angle formed by the extension and the line segment, for example, in the picture here, the angle between CD and BC is called an exterior angle. And remote angles, so this in the picture, BCD is the exterior angle, and BCA apparently is adjacent to this exterior angle. So we cannot, so these BCA is not the remote. So these two, we have these two, angle B and angle A, they are not adjacent to the exterior angle. So we call them remote angles. So that means in this case, what we need to prove is the measure of BCD, angle BCD, is equal to the measure of angle A plus the measure of angle B. That means, in this case, that means this measurement of BCD equals alpha plus beta if we use the symbols in the picture. So first of all, we can always write, of course we can write down m of angle A, but it's easier just to use a letter alpha to denote the measure of angle A, and then beta as the measure of angle B, and gamma as the measure of angle BCA. Because clearly this exterior angle and this interior angle, they are adjacent to each other, so, and they are a pair of linear angles, so they are linear pairs, so we can, if the angle measure of angle BCA is gamma, then of course we can find out the measure of BCD, which is supplementary 180 minus gamma, and then we can use the property of the degree sum of a triangle is 180 degrees. So we should be able to prove 180 minus gamma is the same, is equal to alpha plus beta very easily. So the first one is the hint is to use the degree sum is 180 in a triangle. So next one, if a transversal is perpendicular to one of two parallel lines, it is also parallel to the other line. So we have two parallel lines, M and L, in the picture, and the transversal is T. We know T is perpendicular to L, so the angle between formed by these two is 90 degrees. But we don't know if the angle formed by T and M is also going to be 90 degrees. Actually it is correct, but we need to prove it. So how to prove this other angle in the picture, we call it angle 2, is also 90 degrees? Well, it's very easy if we use the one of the theorems we proved in the video lectures 1.19. That's the first one we proved for parallel lines. So what's given in this condition? So I hope when you write down the proof of the problem, write down clearly what's given. For example, in this case, given we know M parallel to L, and we also know this angle 1, the measure of angle 1 is 90 degrees. So what we need to prove is the measure of angle 2 is 90 degrees. And then when you write down you can just say if you notice, so the hint is to use theorem 1.19. So if you notice, angle 1 and angle 2, they are corresponding angles. Okay, so now the next one is 1.26. We need to prove 3 statements. First of all, we know the quadrilateral is a parallelogram. So if you will recall the first slide, the parallelogram means two opposite sides are parallel. If we look at a picture here, ABCD is a quadrilateral and BC is because we know it is a parallelogram. So in the picture, BC is congruent to AD, and AB is BC is parallel to AD, and AB is parallel to CD. What we need to prove, so what's given will be BC parallel to AD, AB parallel to CD. We need to prove, first one, each diagonal divides the parallel into two congruent triangles. So if we draw a diagonal BD, we need to show these two triangles, the blue one, the yellow one, are congruent. So we can use the congruent triangle conditions we have talked about before: side side side, or angle side angle, or side angle side. Also, again, we have to use the theorems we have proved before for parallel lines. So, for example, we know BC is parallel to AD, and then these two angles marked by a red curve, they are called alternate interior angles. And also similarly, because AB is parallel to CD, so BD is the transversal, and then these two angles with the double marks, they are also alternate interior angles. So by the parallel property, they should be congruent, and then we can use the property angle side angle to prove they're congruent. And then number 2, there are two diagonals, so the other one I think it can be proved easily, similarly. So we just need you to prove one of them. Number 2, each pair of opposite sides is congruent. So we need to show BC is congruent to AD, and AB is congruent to CD. Well, I mean, in the other geometry classes, or you may already know this, that a parallelogram, two opposite sides are parallel and also congruent. But we have to follow the definition here. The definition is two parallel sides are parallel. There's nothing mentioning if two corresponding sides are, or opposite sides are congruent. So we don't know that. We have to prove that they are congruent. So what's given in the second case is still what's given: BC congruent to AD and BC parallel to AD and AB parallel to CD. We need to prove BC congruent to AD and AB congruent to CD. And again, we can use congruent triangles, and that actually we have already proved before. These two triangles are congruent. So it's a direct consequence from part 1. And part 3, the diagonals bisect each other. So in this case, we need to show BE is congruent to ED, AE is congruent to EC. If we can prove one of them, the other one can be proved similarly. So you just need to do one of them, and the other one just say similarly we can prove AE is congruent to EC, for example. So how to prove BE is congruent to ED if we can prove two congruent triangles? And let's find a triangle which has BE as a side, and find another triangle which has ED as the side. And for example, the top small triangle and the bottom small triangle, can we prove these two triangles BEC and DEA? Can we prove them that they are congruent? And or you can prove BEA and DEC are congruent. Either way, it should be fine. Okay, so after we prove they're congruent, of course, the corresponding sides are BE and DE, the corresponding sides of these two congruent triangles. So they should be congruent. So that's how to prove 1.26. So basically, we need to use the properties of congruent triangles. And 1.27, a quadrilateral in which each pair of opposite sides is congruent is a parallelogram. So what's given? The given part is the first part of the sentence before is. So we have a quadrilateral ABCD, and we also know the other thing given is opposite sides. Each pair of opposite sides is congruent. So BC and AD, they are congruent. Also, we know AB and DC, they're congruent. We don't know it. What we don't know is, which is also what we want to prove, it's a parallelogram, which means by the definition, we need to show these two pairs are parallel. Opposite sides are parallel. So the hint is, as shown in the picture, we can draw a diagonal BD, and to show these two triangles are congruent. So we can show these two triangles are congruent, and by theorem 1.20, if we want to show two lines are parallel, and we can show that a pair of alternate interior angles is congruent. And so clearly we know angle 6 and angle 2, they're congruent. So they form a pair of alternate interior angles. And similarly, we can show that the angle 8 and angle 4, they're congruent. So they're also a pair of alternate interior angles, and so we can show BD and CD parallel. So to show lines are parallel, we have three theorems. We can either show a pair of alternate interior angles, or a pair of corresponding angles is congruent, or we can show a pair of interior angles add up to 180 degrees. So we can choose one of them depending on the cases. So in this case, actually, it's very easy to show a pair of alternate interior angles is congruent. So the hint is to use the SSS to show two congruent triangles, and then we use theorem 1.20. Okay, number two, a quadrilateral in which the diagonals bisect each other is a parallelogram. So what's given is a quadrilateral ABCD and two diagonals AC and BD, they bisect each other. That means AE is congruent to EC, BE is